Hello everybody, my name is Mohit Deshpande, and in this video I want to show you guys how we can do matrix operations using NumPy matrices. And you're going to notice that this is going to be really intuitive, and in fact it's going to almost exactly mirror the stuff that we've been doing with matrix math. So first things first, I have to import NumPy, and I'm going to do as NP for convenience. Then I have to declare two matrices, so I'll do A equals NumPy dot array, and then I like to use this kind of notation here so that it actually kind of looks like a matrix. So we'll do 1, 1, 2 for the first row, and then 3, 5, 8 for the second row, and I'll create another matrix B. I'm just going to copy this and paste and change this to be B, and then change some of these values. I'm going to keep the same shape: 2, 3, 5, 13, 11, and 7. Okay. So now, how do we add two NumPy matrices? Well, it's exactly what you were probably thinking. We can use the addition operator. So I'm going to print the result out. We print A plus B. And so you might be saying, wait a minute, but these aren't actually numbers. These are NumPy matrices. How does Python know when to do this? And it turns out Python does know. Python knows that for this addition operator, the two sides, the two operands for addition, are two NumPy matrices. So what Python is going to do is it's going to automatically delegate this plus operation, this sum, to NumPy. NumPy is going to say, well, hey, I know how to add two matrices together, so let me just give you the result. And it's going to do this for us. So let's actually run this code. And here's the result here, and we can see that it matches up to our expectation, right? 1 plus 2 is 3, 1 plus 3 is 4, 2 plus 5 is 7, and so on. So this is really neat. And so now, how do we do subtraction? Well, it's exactly the same as addition, except use a minus sign instead of a plus sign. So it's the same deal here. NumPy knows that the two things that we're dealing with, the two operands, are NumPy matrices, so it's going to go ahead and perform that operation for us. So I'm going to do the same thing. I'll do print A minus B and run that code as well, and we'll see the result here. So you can see we actually have two matrices up here. So if you look at this bottom one over here, then you can see that that's also what we expect, right? 1 minus 2 is minus 1, 1 minus 3 is minus 2, and so on. So addition and subtraction with NumPy matrices is super simple. You just use the addition and subtraction operators like what you're used to. So now here's an interesting question. What if we try to add two matrices in NumPy and they don't have the same dimensions? We know that mathematically this is not something that we can do. It's not a valid operation, but let's just see what happens if NumPy, let's see what NumPy does. So what I'm going to do is I will get rid of this subtraction and we'll just do addition, and I'm going to add an extra row to B so that A and B don't have the same dimensions. So we'll do something like just add a row of zeros. So now B has 1, 2, 3 rows and 3 columns, but A only has 1, 2 rows and 3 columns. So this shouldn't work. So let's see what NumPy does. Hey, look, NumPy crashed. It says value error. Operands could not be broadcast together with shapes 2, 3, and 3, 3. And that's exactly what we expect. What happened in NumPy crashes because we can't add or subtract two matrices with different dimensions. And so NumPy automatically knows that you're trying to do something that's not good, and it will thankfully, very thoughtfully, crash for you. So this is kind of like if your program crashes and you get this error that kind of looks something like this, value error, operands could not be broadcast together, then you know that somewhere you're doing a matrix operation such that you're using invalid dimensions. Your matrices have invalid dimensions for the operation that you're trying to do. So that's kind of how you know this. Anyway, this is just something to keep in mind. And, obviously if we fix it, then NumPy will just run it and everything will be golden. one last thing that I want to talk about is scalar multiplication. So let me just create another matrix. C is numpy dot array, and I'm going to make it a different size this time. So we'll do something like 3, 1, 4, and 1, 5, 9, and 2, 6, 5, and 3, 5, 6. Okay, I'll stop here. So now we have C, and so with scalar multiplication, we can do something similar to what we did for addition and subtraction, except we use a multiplication sign. And again, NumPy and Python are just so awesome because we automatically know that the first thing is a NumPy matrix and the next thing is a number. So we're trying to perform this operation, so NumPy automatically knows that, hey, I see you're trying to do scalar multiplication. So let's try multiplying C by 100. So I'll do 100 times C, and then let's go ahead and run this, and you can see that it works. 300, 100, 400, it multiplies this by 100. And now just to kind of show you, we can reverse this. We can do C times 100 instead of 100 times C, and we should get the same result back. So we'll run this, and yeah, we do get the same result back as expected. So NumPy is super awesome because it automatically knows that the two things that you're performing some matrix operation with involves either both of them are matrices and you're doing addition or subtraction, or one of them is a matrix and the other is a number and you're doing scalar multiplication. And just to show, we could do, doesn't positive numbers, we can actually do negative numbers as well. So I can go ahead and run this and we get negative results back. So this is scalar multiplication, and I've also covered addition and subtraction. So I think this is where I'm going to stop for this video. And so let me just do a recap. We discussed how we can perform addition, subtraction, and scalar multiplication using NumPy, and it's super awesome because if you can just do it intuitively, you just take A plus B, and if A and B are both NumPy matrices, then the result is going to be a NumPy matrix with the appropriate values. Same thing for subtraction, and with scalar multiplication, NumPy knows that one of these operands is a number and the other is a matrix, so it's going to perform scalar multiplication. So that's what we talked about in this video, and then in the next videos, since this is all that there is to it for matrix operations, we're going to kind of get into OpenCV with Python in the next few videos.